So when we talk about simple harmonic motion, there's really only one vocabulary left to talk about. Now there are a few other words floating around, but nothing terribly important. We have damped harmonic, and those have 3 different words. There's a simple and all sorts of stuff, but that we won't talk about that right now. But angular frequency is important in the fact that when we look at the equations for simple harmonic motion, the angular frequency term is there. Now there is a relationship between angular frequency and regular frequency, or what we normally call linear frequency, but we're just going to simply call it frequency. Angular frequency is the measurement of how many complete rotations or revolutions an object has or achieves in a given amount of time. Now that's usually measured in either radians or revolutions, or even rotations. But what we'd like to see it is in radians. Imagine that an object completes one complete rotation in a given second. Then we can say that the angular frequency of that object is 1 revolution per second. Or realizing that in a complete circle, draw a circle, that there are 2 pi radians in that circle. So when we say 1 rotation or 1 revolution, we actually can say it as 2 pi radians. Okay? So when we talk about angular frequency, it's not the same thing as regular frequency. Regular frequency, if you were to draw a mass going up and down, it would look something like this, just going back and forth in that same axis, where angular frequency is spinning. It's a rotation. Okay? And it's typically measured in radians per second. It has been expressed in times as revolutions or rotations. Okay? So that's angular frequency. It turns out that the relationship between angular frequency, now I'm going to give you the mathematical symbol for angular frequency. The relationship between the two is that this term right here, this W, is actually what's known as an omega. That angular frequency is equal to a complete circle, 2 pi, times the regular frequency, the linear frequency. That's the relationship between angular frequency and linear frequency. Okay? So if you need to convert one to the other, that's the way in which we do it. But that's angular frequency.